So today we're going to be doing something with the Maclaurin series, but instead of proceeding the regular way with the Maclaurin series, I'm going to show you an unusual question with an unusual solution with the Maclaurin series. So here I have a question. Let f of x equal ln of 1 minus x over 2. Obtain the Maclaurin series for the function f of x. State the radius of convergence and use this result to show that ln 2 is equal to the series from n equals 1 to infinity of 1 over n times 2 to the power of n. So how do we do this? First of all, you should be able to recognize that this is a very good question. There is actually a principle in Calculus 2 that says you can use the derivative to get the original series. And I'll just explain what I mean in a sec. So first of all, I'm going to write down the function f prime x. I'm going to find the derivative first. And you'll see why, because we're going to use the power series to tackle this. So that would be negative 1 over 2. Over 1 minus x over 2. And I'm going to briefly do a side note right here. And tell you that the power series representation looks something like this. I'll just, it looks something like this. So when you have something like n equals 0, infinity, q to the power of n, don't worry about the letter. It's just another general variable. Put t, put v, put at least Navidad for all I care, is equal to 1 over 1 minus q. Providing that the absolute value of q is less than 1. So I want to make it look something similar to this, and I'm going to manipulate this variable a little bit. Because on its own right here, this is not going to give me a direct answer. So I'm going to do is say it's equal to negative 1 over 2 times 1 over 1 minus x over 2. And x over 2 will be our q value. Okay, so I'm going to put the negative here, and I'm going to combine this. So 1 over 2 x over 2n to the power of n. And that, furthermore, is equal to negative. So we'll do this series again. Zero, infinity, negative. Okay, so xn over 2n plus 1. So this is this series representation for f prime x. But to convert it back to f of x, you can treat this like take the antiderivative of this. And it actually intuitively makes sense, because when you think about it, the Taylor or Maclaurin series of is defined as the Taylor or Maclaurin series of a function is defined as an estimation of that function using polynomials. So I'm going to write that down so you don't forget. So Taylor and Maclaurin series is the polynomial estimation series of a function. And because when you take the antiderivative by the addition derivative law, I add caps on the derivative addition in derivatives and integration, you can take the antiderivative of a series. So if it didn't become quite clear what I was trying to say, like I'm just going to get rid of this text block. I'm just going to delete it right now. So basically, f of x, you can just take the integral like right here. So is equal to negative so okay, let's see. N is equal to 0 to infinity. X to the n, so like x to the n over 1, n plus 1. Remember, the antiderivative of x to the power of n is x to the power of n plus 1 over n plus 1. Over 2 n plus 1. And because we took the antiderivative, we need to add a c here. So it's equal to c minus this. I wrote this little weirdly. You take the integral of this. So yeah. You know what? I'm gonna try that again. So just in case you guys didn't, I mistakenly already did the integral. I meant it like this. So the negative, the integral of, I'm not going to say a word right now. X. Okay, and as I already said, minus, and then that's c minus this, so c minus n is 0, infinity, x n plus 1 over 2 n plus 1 n plus 1. All right, we have to find the c value. So we have to find the value of what's c. So let's the way you find the value for c, put any constant value for x, and then in here in the series, the easiest way is to set x equal to 0. It works out every time. So f of 0 is equal to ln of 1, which is 0, which is equal to c minus n equals 0 to infinity. Just plug in x equals 0 for this series. The numerator is 0. Denominator is 2 n plus 1 n plus 1. You're going to get 0 regardless. So that just cancels out to equal 0. So that means c is equal to 0. It's not always equal to 0, but in this question, it is. Now, next part. So f of x just equals this part, basically without the c. So I can just cut it short and then just say this. This is the value of f of x. Now, let's see, what do I want to do now? All right, so we need to find the radius of convergence. That's what the question tells us. I'm going to say that is equal to finding r. So not what r equals. Here's how we find r. We're going to use the ratio test. And here's how the general formula for writing the ratio test. Lim n goes to infinity a sub n minus 1. No, sorry, a sub n plus 1 over a sub n. So let's apply that here. Lim n goes to infinity. Let's see. A sub n plus, okay, x n plus 2. Let me think now. Yeah. So x to the n plus 2. Remember, what I'm doing the a sub n plus 1 right now. So x to the n plus 2 over 2n plus 2, n plus 2, yeah, 2. Okay, this is a sub n plus 1, so we need to divide it by a sub n. A sub n is just x n plus 1 over 2n plus 1 times n plus 1. Okay, so we can just work out this division. I'm gonna first say lim as n goes to infinity. For x, okay, so let's look at the numerator. X n plus 2 over x n plus 1, that's just x. And the bottom, 2n plus 2 over 2n plus 1 is just 2. N plus 2 over n plus 1. So it looks something like this. But remember, as n goes to infinity, the value of n plus 2 over n plus 1 just becomes equal to 1, because it's like infinity and these 2 and 1, that's like infinity plus 1, that's like adding a grain of salt into the Pacific Ocean. Do whatever you want, it won't make a difference. So n plus 2 over n plus 1 is equal to 1 as n approaches to infinity. So you get x over 2. Now, when you're finding the radius of convergence, you do the ratio test, you get a certain result, and then you say that this result is less than 1. X over 2 is less than 1, which means x is less, absolute value of x is less than 2. So radius of convergence is 2. And it makes sense because the Maclaurin series is about where x equals 0. So yeah, absolute value of x is less than 2. Now, we still have to do one more thing here. We still have to show that the series result, this ln 2 is equal to this. So remember, f of x is equal to remember I said c is equal to 0, so that's just equal to n equals 0, infinity, x n plus 1 over 2n plus 1 n plus 1, 2 to the power of n plus 1 times n plus 1. Since here they had it as n plus 1, I'm going to adjust it here to n plus 1 as well. So that's equal to negative. I'm going to say n equals 1. Infinity into infinity. Okay, let's see. The way I adjust from n equals 0 to n equals 1 is I look at the first term. So when n equals 0, this would be x to the power of 1. Okay. When n equals 1, that's x to the power of n. So I get the same term. Down here, 2 to the n plus 1, 2 to the power of, and n equals 0, that's 2 to the power of 1. When n equals, that's 2 to the power of n times n plus 1, n. Yeah. Let me know if you want more help from changing the value of the series. Okay, so there we go there. Now, we want to show ln 2 is equal to this. You can either try x is equal to, let's see, x is equal to -1/2, or x is equal to 1. When you try x is equal to -1/2, that doesn't work. You can try yourself to see. So but I spared you the hassle of doing it. Let's say x is equal to 1. X is equal to 1, so f of 1 is equal to ln of 1/2, which is negative ln 2. F of 1 is equal to negative one over, so x 1 to the power of n over n times 2 to the n, which, okay, so n is 0 to infinity. No, sorry, n is 1 to infinity. Meaning that this is just equal to infinity 1 over n times 2 to the power of n with the negative. So negative ln, and this is equal to negative ln 2. Take the negative sign away on both sides of the equation. You get ln 2 is equal to the desired result. And now we are done this question. Check mark, big happy face. We are done. So that's all for today. If you have any other questions, let me know. I love to stay, but for now, I gotta jump. I'll see you guys on the other side of the bridge. Catch you next time.